Hey folks, Madison Dixon here, Associate Director of the Mississippi State University Agricultural Autonomy Institute. I'm coming to you today from the Mathis Black Belt Experiment Station here in Brooksville, Mississippi, and we're in the process of filming our flow rate video for the spray drone training video series. And I wanted to take this opportunity to tell you just how important this topic is and just how important this step is in the use of any type of spray drone technology. So calculating your flow rate is so incredibly important because this is how you can ensure that you're applying any given product at the appropriate rate that's called for by the EPA label instructions for that product. And many of these spray drone systems are not equipped with onboard pressure sensors. Therefore, it's very important to use any kind of pitcher or graduated cylinder to manually collect your product as you're doing this calibration, and then again using that information to make sure that you are putting out an application of any product at the appropriate rate. Our concern is that many operators have missed or overlooked this very critical step and are trusting the spray drone system itself to be able to do this autonomously. While most applications in terms of flight are better performed autonomously, it's still incredibly important to manually calibrate your flow rate to ensure that you're applying these products accurately based on EPA label instructions.
Today we want to take a look at flow calibration and what that is with the spray drone. Primarily, it's really just making sure the drone is putting out the amount of product that we want it to. So let's go take a look and see how that's done.
So if you guys are in position, we're going to start in 3, 2, 1, go. Stopping in 5, 4, 3, 2, 1, stop.
All right, great. That's the first part. The next part is we're going to take one of these graduated cylinders over here and just pour each of these into it and measure it. All right, so we're just going to pour in like this. Great. All right, so we have about, I'll go down like this. We have 190 milliliters.
Stopping in 5, 4, 3, 2, 1, stop.
All right, great. All right, so we'll come over here, Caleb. I'll set it like that. Pour in. And at this point we have 2250, like 225 milliliters.
225 milliliters is 7.60 fluid ounces.
Yeah, 15.2.
Yep.
So we need to come on up a little bit more. Maybe take it to 70%.
We are starting in 3, 2, 1, go. Stopping in 5, 4, 3, 2, 1, stop.
And pour this in here. Well, that's what we want. We wanted what, 280, 281.
281 is the maximum.
Yeah.
This is probably 280, 290.
All right. So here, mine's reading 250 over here on this one.
Awesome.
Let me pour it into here and we'll put yours in there.
Did you have that kind of pretty well all encapsulating the nozzle? Oh, yeah.
He's got more than me. I would have lost it. Go ahead and just pour it in there and let's see what we got. No, it's just, it's practice filming. Yours is a little higher than mine, yeah.
260, 270.
So that we have variability between the nozzles. Okay, so that's going to be.
Nozzle. I've been collecting on
No, we actually want to show that there can be differences between nozzles, and then we want to limit that variability.
Different pumps.
Well, that's true too. Yeah. You're on that same pump, right?
Yes, sir.
Feeding that side. You want to? Let's see what we got here.
No, I think Watson's on the same pump. James would have been on the same pump.
Oh, it feeds that side. One feeds that side. One feeds this.
Yes, sir.
Yeah. 250, same as me. It could be the pumps.
And we're starting in 3, 2, 1, go. Stop in 5, 4, 3, 2, 1, stop.
And I'm reading about 250 milliliters on this one. 250 here. Let's go ahead and see what you have, Watson. Okay, so this one is reading 165, 170.
Wow,
Yeah,
that's low.
really low. Both of these nozzles. All right, let's see what you got.
Maybe the diaphragm's got a problem.
I think so, because he's reading high and Watson's reading super low.
This one we're reading 250, same as me. That's good.
Same.
And then Jared, let's take a look at yours.
Another 280 probably.
Yep.
And this is off of the same.
I wonder if it's designed like that, since it's gonna be leaning forward, or it goes back.
All right, see what we see on this one is about 275. Yeah, so those are consistently high.
Pulled off of this one.
All right.
It looks kind of low.
Here we're reading, again, 275. So that whole quadrant over there, 275. And you're low at 150, 160.
We've got some pressure loss, or obviously we've got an issue on this side. That one is getting higher than everybody, and that one's getting lower than everybody. At least for you guys, you're consistently getting the same readings off the same, you know, separate pump.
Yeah, these are equal over here. Big difference over there. Hey, so what we're looking at right now, we're seeing a discrepancy between the nozzles. Over on this side, we're running about 275 in 30 seconds. Here we're running about 100 milliliters less. We're trying to figure out what the problem is. Like, why are we seeing such discrepancies? Because in the field, it's going to make a big difference. You know, the system's going to give us a total system flow rate to give us the application rate that we need in the field, but we're not getting uniform distribution around the drone. And so what it's going to do is probably going to give a little higher pressure, low flow rate to one part of the drone, less on the other. That's going to affect our pattern as well as deposition in the field. So we got to figure this out, and that's what we're doing right now.
Here we go, starting in 3, 2, 1, go.
Let's see, it looks different. Okay.
Stopping in 5, 4, 3, 2, 1, stop.
All right, so let's go ahead and dump out what we had here. Okay, let's take a look, Watson. All right, so okay, so we're a little higher on this one. We're at 265 on this one for that set. So it's higher than for this one. It's closer to actually what we want. Let's see where I put this other nozzle. So that one was 265. And this one here is about the same. It's a little bit higher, 265, 270.
Yep.
So those are doing okay. There's just something right here on this line. All right. So let's take a look. It's probably okay. Could be right here. Looks good. Jerry, can you take this one off right here and take a look at that strainer on there? So each of these have a strainer in them to help filter out the material, you know, like particulate matter, dirt, debris, that kind of thing. So we got to check and make sure that these are clean. If they're clogged up, they're not going to allow the flow that we want through there. A lot of times it's good to take some clean water and just flush these off. Can you grab some clean water? We'll just rinse these off real quick while we have them. Since we're just using water right now, we're not wearing gloves. But if we had chemical in the tank, then we would definitely use some protective equipment to protect our hands. Great, thank you. All right, how's your look over there?
Looks pretty clean.
All right, so I'm just gonna see if I can grab this and. So the nozzle goes down first, and you have a rubber gasket that goes in here, and then the strainer goes up inside just like this. The other thing that you want to do is you want to take and make sure, since these are flat fan nozzles, you look at the forward and the aft portion of the drone, and you want the fan angle to be perpendicular to the flight path. And so on these, yeah, this is pretty close, but I need to rotate it just a few degrees to get it so it's spraying directly across like that. We'll do the same thing for you, Jared, on your side. But make sure that those fans are going straight across, perpendicular to the flight path of the drone. So let's test these again if we can. All right, here you go, Watson. If you want to put one under, let's do this one right here and one right there, Jared. So we're going to test this again. Madison, whenever you're ready.
All right, starting in 3, 2, 1, go.
So again, we're doing this for 30 seconds. We're just going to collect spray for 30 seconds, and then we'll multiply that by 2 to get our ounces per minute or milliliters per minute, whichever unit measurement you like to use. And we're looking for this one, we're looking for 19 ounces per minute, which is equivalent to 0.15 gallons per minute, which would be our flow rate at 40 PSI. That's since none of these drones have pressure regulators, or, well, they have flow rate meters on there, but they don't have any pressure gauges. The only thing we can do is really look at a reference flow rate. And if we get it to 0.15 gallons per minute, we know we're at 40 PSI or thereabouts. All right, so let's take a look at this. So this one, we are still at 150 milliliters. So it's not the strainer. It's something else in the system that we need to figure out. Let's take those nozzle tips right there that we had 265 coming out of and switch them with these. Let's see if it's the tips that are causing some of the problems that we have. There, let me put this one on here. Again, we'll make sure the orientation of that tip is correct, which looks good there. Great. Okay, looks good. Let me put a strainer in here. Switch this out. All right, so this whole process is just called troubleshooting. Oh, here we go. We're over here. We're just trying to figure out what's causing the difference in the flow rate between nozzles. Again, I want to get this a little bit perpendicular to the flight path, and we'll switch these out. So now what we're trying to do is we switch the nozzle tips from the high flow rate section to the low flow rate section. We're going to try to see if it's just the nozzle tips that are the problem on this. So Madison, let's run another 30 seconds.
All right, starting in 3, 2, 1, go. Stopping in 5, 4, 3, 2, 1, stop.
All right, see if we got any difference here. And no, as you can see, we're still at 150 milliliters on this, even though we switched out the nozzle tips. So on Watson's, we're at 150. Let's see what we have here for Jared's. And the jug feels a little light, Jared, so wouldn't surprise me if we're about that same on here. Yes, 150. So it's not the nozzle tips, it's not the strainers, it's something else. Now if we look at this, these sections right here, we didn't have any problems with these, right? Right. But we have problems with this, and they share a line that comes out of the pump over here. It has a Y that splits right in here. It's a push to connect kind of fitting, 8 millimeter, close to a 1/4 inch, not exactly the same, but really close. And then the line comes in here. So there's a difference between this and that, something going on. So what we see on here that looks a little different than the others is it looks like it may be a little pinched right here. This tubing looks like it may be restricted right here as it goes into this fitting. So we're going to take this apart and we're going to take a look at it and see if that's the problem. First we do this push to connect. We release this right here. We take this little clamp, we push that together, and then we just spin this off. We pull it out. And if you look at that, look how that's pinched. That's going to restrict our flow, and that's the problem that we're seeing right here. So what we're going to do is we're going to cut another piece of line, put this in, and retest. What we just did is we replaced that tubing that we saw was kinked, and we're going to retest. Madison, whenever you're ready.
Starting in 3, 2, 1, go. Stopping in 5, 4, 3, 2, 1, stop.
All right, Watson, let's see what you got there. All right, so much better. We are close to 250 milliliters on that now.
Excellent.
Yep, and so that matches pretty close to what you have over there. A little bit different, but much closer than 150. Was this yours, Jared, right here? And this was on that second nozzle as part of that set? Okay. So the twin nozzle over here is also at 250. So we're in good shape with these. These are both at 250, which matches what we were getting over here. So the next thing we want to do is we wanted to get up to 280 milliliters in 30 seconds. That gives us 19 ounces, which is equivalent to the 0.15 gallons per minute that these nozzles are flow rated for at 40 PSI. All right, Madison, let's go ahead and take it on up. We're at 75, let's go to 85 and see if we can get what we want. Watson, here you go. And Jared, let's go back to the quadrants with you doing that one over there. Watson, you here. James, you there. So what we're going to do on this now is we're trying to get that higher flow rate so that we know that we have 40 PSI coming out of these nozzles. So we're shooting for 280 milliliters in 30 seconds. Madison, whenever you're ready.
Starting in 3, 2, 1, go.
Now the reason we have to do this is because there's no pressure gauges on these drones. I don't know of a single drone that has a pressure gauge on it. They have flow meters and they're trying to regulate that flow to give you the application rate that you want in the field, but there's no real independent verification of it, of pressure. And pressure affects your droplet spectrum and your flow rate and your application rate as much as anything does. So this is why we want to do this test. All right, Watson, let's see what we got. So if we look at this one, we're up to 260 milliliters on this set right here. Jared, let's take a look at yours. So 260 there. And we're at, again, 260 for Jared, so that's a good match. Take a look at yours, James. James has 260 on his, which looks great. And then mine is this one here, the back left quadrant. And we have 260. So they all match up, okay? So that's a really good sign, but we're not quite at our 281. So let's keep going.
All right.
We were at 85%. All right, let's take on out. Let's do 100%.
100%
Yep.
pump power.
Yep. All right, let's do that again. Watson, here's yours. This should be our last one because that's all we got. So what we're trying to do now is we're trying to get up to our 0.15 gallons per minute as these nozzles are flow rated at 40 PSI. So we're doing a test now with 100% pump power. Madison, whenever you're ready.
Starting in 3, 2, 1, go.
I can feel the difference. I see a little bit of leak right there where Watson is. Oh, we got a hose broke. All right, this is a good test. So this shows where the weaknesses are in the system. We had a little leak right there where Watson was, and this hose blew off over here. So we're gonna fix those and try that again. So we just had a blowout on this line right here when we put it under full pressure. So we went ahead and cut off that last little ½ inch or so that was a little bit compressed. And then what we're gonna do is go ahead and put it back in. These are push to connect fittings. And so you just push them in, line it up, push it in like this. And then you wanna test, you just pull on it a little bit. Once you put it in there, if you can pull it out, it's still not right. So there's a problem here. See, I can just pull that right out. So we're gonna have to do something different with that. We're either gonna have to replace this coupling or see if we can trim off some more, but we already trimmed off pretty good, so we'll have to figure that out and make sure that's nice and tight. So what we saw here is that this connection was impinged, and what was happening is when this collar is tightened down to secure this arm, it was pushing in on this push to connect fitting and not allowing it to snug it up like it needed to at the high pressure. We didn't even notice it at the low pressure, it's just when we went to 100%. So what we're gonna do is we're gonna release this collar here. We're gonna loosen this connection right here for this coupler. We'll get a little hex wrench, probably 2.5 millimeter. We're gonna rotate this coupler, this fitting, out of the way. We're gonna come back in and retighten it right here to where it's out of the way of the arm, coupler arm, right there. And then we're going to reconnect, okay? And then we're gonna do our little test where we pull on it and it's nice and tight. So then we go ahead and reconnect this arm lock right here, the collar lock, and we can see it's not impinging on it at all and it's still nice and tight. So in the last segment, we ramped up to 100% power to get our flow rate that we needed, 40 PSI, and we had some pressure losses. We had a blowout on one of the hoses and we fixed that and got it out of the way. So we're gonna go ahead and retest now at 100%, see when we get up to our 19 ounces per minute. Madison, whenever you're ready.
Starting in 3, 2, 1, go. And go.
All right, so what we're noticing, the hose look really good over here that we fixed earlier. We got a little leak right here on this check valve. We'll have to check that out. It's not a huge leak, but we still need to fix it. All right, so Watson, let's take a look at yours first. All right, this is just about perfect. We are right at 300 milliliters. So we overshot just a little bit, Madison, but that's all right. So we're looking for consistency here, but we're also, our target is 280 milliliters. Just see what we get out of each of these. So this one here is right at 300 milliliters as well. That's great, good consistency. All right, so we have James's here. Take a look at this one. And we're at a little under 300, but really close. Maybe about 295 on that one. And what we're looking for is plus or minus 10% between nozzles. You'll see some nozzle variability, but we want to keep it plus or minus 10% of the average. And this one's right at 300. So we're really good on that one. The only thing that we need to do, Madison, I think we need to maybe just bring it down just a little bit, maybe to 95%. Okay. We're looking at 280 mils, and we need to fix this, this little leak that we have here, Watson. All right, so let's take a look at that. So within here, in this check valve, we got a little diaphragm, and it could be that this diaphragm is just worn. See, it's a little rubber diaphragm like this. Could be this is just worn, so we're gonna replace this and see if we can seal that up. So we're gonna take this check valve, we replace the diaphragm on here. We're gonna spin this back on and retest. All right, so in that last one, we were a little over our target. We were shooting for 280 milliliters. We were at 300 on average, basically between the four of us. So we're gonna bring our pump power down to 95% and retest. Madison, whenever you're ready.
All right, starting in 3, 2, 1, go.
Now you'll notice there's a lot of little droplets floating around out here. These are XR nozzles. They typically give you kind of a fine spray. They're extended range. XR is what that means. Anywhere from 15 PSI up to 60 PSI, they work pretty well. But they do get you a little finer droplet spectrum. So that's probably what you're seeing here. Really good if you're putting out fungicides or insecticides, but from a drift standpoint, you got to be careful. All right, so let's take a look at this, and we are right at 280. Madison, we nailed it. Yeah, that looks great. Let's check yours, Jared. Let's see what we got. We're just confirming that each of these nozzle sets is approximately the same. Yep, we're at 290 right here. That still looks good. Let's take a look at James's. And we're at 280 right here. That looks great. And again, if you can get plus or minus 10% of what your target is, you're in good shape. And we're at 280 there. So we're in good shape. Excellent. 95% is the trick. All right, so we just showed you how to do the flow rate calculations for the drone and to do that calibration. Now there's several reasons to do that, not the least of which is to make sure that all the nozzles are plus or minus 10% of each other in flow rate. But then in addition to that, we now know, based on what we just did, that we're close to 40 PSI on these nozzles because the manufacturer states these are 0.015 nozzles, 0.15 gallons per minute at 40 PSI, and that is the flow rate that we got in 1 minute. So we know we're really close to 40 PSI on that. None of these drones have pressure gauges, so that's about the only way you can do it. There's another little trick I might show you in a different segment, but what that does though is at 40 PSI, the manufacturers, the nozzle manufacturers have published what that droplet spectrum is for each of these nozzles at 40 PSI. So if a chemical label says you have to have a medium or a coarse spray for a particular application, you know if you're at 40 PSI and the manufacturer says for this nozzle, that's going to give you a medium or a coarse spray, you're right on target. Thank you very much. We'll head to the field now and show you what that looks like for calibrating on the field.